This is the famous formula for the angle between two vectors. But where does this come from? Let's prove it. We'll start by completing the triangle with this vector and noting that this vector must be b minus a. And then, using the cosine rule, we'll relate the lengths of the three vectors to the angle theta. Say we have vectors a and b with generic components a1, a2 and b1, b2. Here we're assuming two-dimensional vectors, but the result can be extended to 3D very easily. b minus a is just the displacement vector between the two. Its components are b1 minus a1, b2 minus a2. Okay, now then, the equation involves the lengths of the three vectors, and these can easily be obtained from the Pythagorean theorem. Notice that the equation has the squares of the lengths, and so we'll lose the square roots. The equation becomes this is equal to this plus that, and then minus 2 length of a, length of b, cosine theta. So let's work with this equation now. We'll expand the two binomials on the left-hand side, giving us b1 squared minus 2a1 b1 plus a1 squared, and the same thing for the second binomial. And after doing this, we see a lot of cancellations. b1 squared is common to both sides, a1 squared is common as well, and the same can be said about b2 squared and a2 squared. So we're only left with these terms, which all have a negative 2. So let's divide both sides by this negative 2. And we now see a1b1 plus a2b2 on the left-hand side. And this is nothing but the algebraic definition of the dot product. With these two vectors a and b, the dot product is defined as the sum of the products of the respective components. So the left-hand side is nothing but the dot product between a and b. Let's plug that in. With this, we can solve for cosine theta by dividing both sides by the length of a times the length of b, and so there you have it.